Hello students. In the last lecture we have seen that how to form any differential equation by an ordinary equation. So suppose you have a ordinary equation like a cos x plus b sin x, and you see that this ordinary equation is satisfying this type of differential equation. So this is called solution of this differential equation. So if you have to find solution of any differential equation, so you have to find out the function y, which is the function of x, that is satisfying that equation. Now if you double differentiate y and put the value of this double differentiation and the function value y, you will get answer 0. This means you have to find out a function y of x which is satisfying this equation. So this is called solution of that differential equation. So in next topic we will see different method to solve differential equation. So we will go step by step. So first type of differential equations, and you will see that differential equation with first degree and first order. And you have seen in last lecture that the maximum differential term is called the order of that equation, and the power of that maximum differential is called degree of that differential equation. So suppose you have a differential equation like this: x cube whole cube plus d2y by dx square whole power 2 plus dy over dx whole power 5 plus y equal to 0. So you can see that the maximum differential term is this one. So the order will be 3, and you can see that the power of the maximum differential term is 3, so the degree will be 3. So this equation has order 3 and degree 3. So we are discussing equations which are first degree and first order. Means you will have some equation like this is dy by dx equal to some function fx or some function of f1. So you will solve in first type this type of differential equation, in which the maximum differential term has order 1 and degree 1. So there are different types of such differential equation, and also there are many methods depending on the type of differential equation or the approach of the differential equation. You can apply different methods to solve or to find out the value of y. So first method which we are going to talk is variable separation. This is the first method. So as it is clear from the name itself, means in this method you separate the variables and then solve the equation. So this may be dx equal to some function of fx and dy. You may have such type of a differential equation in which with the term dx there is a function of y, and with the term dy there is a function of x. So you will separate the variables, means you will collect the function fx, all the term having x and dx on one side, and all the term having y function and dy in one side, and then you can solve the equation. So we are gonna talk this such type of differential equation which are having first order and first degree. So first method is variable separation methods, which we separate the variables. I think this we have done well. So we will do some numericals based on this method. So first method of first numerical is x plus 1 dy over dx equal to x into y square plus 1. So now if you see this equation, here is the function fx and y mixed in one side, and also the function y and x are mixed in right hand side. So by the using method variable separation, you will separate the y terms or the term containing y in one side and the terms containing x in one side. So if you see that this is dy and this is function of dy, so you will bring this function to one side, and for x you will write x prime x plus 1. So you have separated the variables. Here is only the function of x and here is the function of y. Now if you have to find out solution of this equation, or you have to find out y, so you will integrate this function or this equation and you will get the value of y or the equation which is satisfying this differential equation. So to get the value of y or to get the value of that equation which is satisfying this differential equation, you will integrate both sides. So you will get integration this and this. So if you see this integration, so this is the integration of tan inverse y and equal to, so to solve this differentiation, you know that in such type of integration you first break out it into partial fraction and then solve the integration. So we have learned in 12th that such type of integrations are done by partial fraction. So first you change this type of function into partial function, and then you will be able to solve this integration. So if you change this integration in partial differentiation, you will get 1 minus 1 by x plus 1 into dx. So again we will have tan inverse y equal to, if you differentiate this term, now you will get x minus log of x plus 1, and you also add a constant c, as the differentiation of c is 0. So here must be any constant, so you add a constant c. So this equation tan inverse y equal to x minus log x plus 1 plus a constant 1 c is the solution of that equation, which words we have to solve. So I think it is clear on all. So in this method is applicable for first order differential equation with first order degree. So we will do some examples based on the variable separation method. So our next question. Next question is that you have a function x y squared plus x dx plus y x squared plus y dy equal to 0. Now if you see these equations, these are mixed variable with x and y, dx and yx and dy with intermixed. So first you will see that can you separate these dx or x terms one side and y terms in another side. So first your observations must be that can you separate these variables in different sides. So if you see this equation, you can take common x and you will get this term, plus here you will take y term common and 1 plus x square dy equal to. Now if you see this equation, so it is clear that you can separate term x and y from one another. So if you see this equation, you can write this as 1 plus x squared d. Now in next step we will separate x term on one side and y term in another side. So you will get x by 1 plus x square dx equal to minus y by 1 plus x square and dy. Now you can integrate both sides. Now if you see the integration of this type of functions you have done in 12, so for this integration you will get log of 1 plus x square and 1 by 2. This will be equal to minus 1 by 2. The function is same. You will get log 1 plus y square, and again you have to add a constant, and this constant is on your choice. So depending on the different questions you have to select different type of constant. You may take it as a C or any other constant, and you can write the constant in symmetric way as there are 1 by 2 in all terms. You can write this constant with symmetry with the other terms. You can write it C, answer is correct, and you can also write it 1 by 2C, the answer will also be correct. So this term has been cancelled out. We have got log 1 plus x square equal to minus log 1 plus y square and plus a constant C. Now you can take this term into the left hand side. You will get log 1 plus x square plus log 1 plus y square equal to C. Now you can write this like 1 plus x square y plus y square equal to, sorry, this is plus sign, so these both function will be multiplied as 1 plus x square into 1 plus y square equal to some constant C. Now if you see that, if you write this constant as log A, so as you know that the constant is on your choice. You can also write the constant log A as this is this will be some symmetric problem. So you can write this constant C. This answer is also correct, but you can also write as a in symmetric form. So you will write this as log. So if you see that both sides are log, the solution will be 1 plus x square into 1 plus y square equal to some new constant. This means this question or this answer will satisfy the given equation we have seen in question number 2. So we will do again some questions. So third question is that suppose you have a function dy by dx equal to x into 2 log x plus 1 and whole divided by sin y plus cos y into y. So again, first you have to observe that can you separate these two variables for y terms in one side and x term in another side. So first observation is that, so this is clear that you can separate without any problem x term one side and y term on the side. So you will get sin y plus y cos y dy equal to x 2 log x plus 1 into dx. Now again you will differentiate, you will integrate this side, and you can see that this integration of this sin y will be minus cos y And if you see this function y cos y, so this is the product of two terms y and cos y. So you will apply the product rule for integration. So this will be cos function into integration of second function, which will be sin y, and you get minus into integration of differentiation of this first term 1 into integration of this term. So you have got sin y and dy. So this is a simple numerical, as you have seen that this type of integration in your 12th. So I have applied the same formula, first function into integration of second minus integration of now another differentiation of first function into integration of second function. This will be equal to, again you will apply same rule for these two functions. You have 2, we will write outside, and you will have x log x. Again there are two functions, so integration will be first function into as you know that you do not know the integration of log x. So if we take x as a function first and log x as a second function, so we will not have an integration of log x. So we will consider x as a second function and log x as a first function. So you will get log x into integration of first function will be x square plus 2. Then you will have sin minus, then differentiation of this will be 1x, and this term will be same. Then another sign will be integration of x, so you will get x square by 2, and you will write a constant c. Again we have left this integration, so this will be equal to, now you will have minus cos y plus y sin y, and integration of this will be minus cos, this will be cos y, equal to, here these both terms will be cancelled out. You will get x square log x minus the term also cancel out. You will have minus x square by 2 and plus x square by 2 and plus a constant. These two terms will cancel out, and this term will also cancel out, and you will have y sin y equal to x square log x plus 1 constant c. So you have solved these equations, and this means that this last solution or this last function will satisfy this differential equation. Now we will stop here, and I will provide you some numerical you have to learn in your notebook. The first function is that dx by x equal to tan y dy. Second function is that dy by dx equal to root of n minus pi square root of x square. Third question is that 1 plus x square dy minus xy dx equal to 0, and the last one is some trigonometrical function such as tan y dx plus sec square y tan x dx equal to 0. So I have given these four numerical and you have to solve, and if any student is solving any type of problem, you can ask me on my personal WhatsApp number or by any other method. So we will stop here.